Are you on Zoom right now?
I am like one little Zoom for me, individual Zoom. All right, class, let's keep on going here. This is 1.2. Yeah, sorry, go back real quick here. Data classification. How to classify data? What are stuff we do? How do we think about all the different types of numbers, categories, stuff like that we do? So let's jam, then we'll talk about collecting them. So let's go with it. First of all is qualitative data. Types of data. Qualitative data means it consists of stuff like labels, non-numerical entries, or attributes, or like nature, birthplace, eye color. Those are all considered different types of. Qualitative just means non-related to computational numbers. Now, the little thing is, we sometimes use numbers, but we don't use them as numbers. Can anybody give me a time where there's numbers there, but they're really just a label? Yeah. When do we use numbers? But the numbers is really just a label. It's not really a number. Like if you add those two numbers together, it would not give you the other number. That's called computational. I'm thinking like student ID numbers. Is that right? They're numbers, but they're really not numbers. That's just a label for them, right? Now, like Social Security number, perfect idea. Yep, right there. Classroom numbers, right? You know, it has an R in front of it, but we are class 8 or classroom 8. Classroom 9 is not anything bigger than classroom 8, right? There's no connection to the quantity of it and the number. So that's where we're like, okay, that's just a relation. So you could have numbers as quality data, but it's not really numbers. Okay, next is quantitative data. Now this one, it means that somehow the number could be measured, or somehow the counting process makes sense. High school. How many of you guys had locker numbers in high school? Yeah. Did locker number 3, was it 3 times bigger than locker number 1? No. So that was not qualitative data. It was qualitative. This one now you start measuring stuff. So age, yes. Weight of something, yes. Chemistry, yes. So we're gonna do a little more with this stuff because there's actually several different kinds of quantitative. So let's start branching out in our minds, right? Branching out in our minds, all the different types of numbers we use and how do we use them. Okay. And they call them levels. The book just calls them levels. I mean, like that's a great way to. Okay, let's jam though. Table shows 14. Let's. Since we're going to have to do a few things, let me skip a few things. We'll practice with the rules a little bit. Everybody okay there? That's qualitative data. It's sports and head injuries in sports. Don't need to write it down. Just kind of think with me. Left side qualitative data. Right side are the numbers are there, but is it actually quantitative data? Yes or no? Head injuries. The number of head injuries. Yeah, that's qualitative. Okay, but what we were trying to get to is levels. So here's our levels now. So levels of measurement. And this is breaking up the numbers that we're talking about. For the qualitative. So how do we break up qualitative data? If you want to put on here, maybe the best way to do it is just put qualitative data. This is the breakup of qualitative. So nominal in the math world, nominal just means you have a name for something. Good. Somehow books call it categorical data. File calls categorical data. And he has 2 master's degrees in statistics, so he's doing something right. All right, categorical data. We are categorizing stuff, we're labeling things, we're doing that. There's no mathematical computations being made out of this stuff. Then we have something called ordinal data. Ordinal data now could be qualitative, could be quantitative. Could have numbers in there. You could arrange them. You can rank them. But it makes no sense to add the 2 together. Add the 3 together. So lots of writing next 2 sections. We're going to do definitions. 3, 4, 5, we do lots of math. Chapters 3, 4, 5. And please do, while we're doing the 10-minute break in the class, please go outside, undo your mask, breathe real fresh air. It does wonders. I've looked at so many, looked at quite a few of mask wearing stuff. Does it prevent or not? And there's no conclusion whether they do or not. So we can maybe take a look at those. So yeah, mask mandates, but they're not. It's inconclusive whether they have. In Norway, they did a humongous study, 20,000 individuals, and they concluded indoor mask was actually worse. Outdoor, it was banned. So,
even if we did so the school make us wear, even if we children were doing study.
right, yeah. And, you know, there's it's kind of like which battles you want to fight, but then at the same time, you stand for yourself, right? There's a teacher yesterday, he said, I'm not going to wear a mask. So he was fired from job. And like, that's my stance. That's where I'm going to stand, you know? And that's, it's the power to him if he stands there. That's cool. I mean, do you agree with that? And then the big thing is mandatory vaccinations, right? That's the big thing. Are you for and against it? You think people have freedom of choice, or is it a collective thinking of the common good? Like, hey, that's there. Okay, let's take a look at it and see if this makes sense. I'm picking up people, okay? You four. Number 1, nominal data or ordinal data? Explain your reasoning. So this is the top 5 occupations with the most job growth projected for that. All health industry, I wonder. And this is kind of cool, guys. Look, you see that little, it says source, right? U.S. Bureau of Labor Statistics, which means I'm not pulling this out of thin air, which means that the data is actually coming from that right there over there. The book has a publishing date of 2019, so all the sources probably are about 2018, 2019 studies, which is kind of cool. So notice, man, that's interesting. 1, 2, 3, and 4 are all healthcare industries right now. 5 is fast food industry, and then retail number 5. That's so if you want to get into an industry that has some room for growth or industries that are growing. Okay, people are all yours. Go for it. Nominal or ordinal. So let's go back real quick here. Nominal means it's only categories. It's names. You only have names and that's it. There's not a single number there anywhere. Ordinal means you could have numbers, they could be arranged, but it makes no sense to add 2 plus 3. Good? Bam, I go with ordinal. Ordinal, yeah, there's numbers there. It's a listing of, there's a ranking even, that's cool, but it does not make sense to add 1 plus 3 equals 4. That doesn't make sense. All right, and the next one. Ryan, you're on the list. I'll help you out, start from N. Nominal, right, just, it's categorical, right? We just split it up into different categories. That's it. All right, now let's jump to the other side, internal level of management. Okay. So if you want to put this, put quantitative across the top, here on the side of your notes, quantitative. Quantitative, and the level of measurement is internal level measurement. I don't know why they use these dumb words. You should just put quantitative data. Okay, they should be ordered in two different groups. Always think about two different groups. So there are differences between entry, yes. The differences are meaningful. So if you add 1 + 3 is 4, that makes meaning here. The one thing that we kind of have to think about is this one right here. It says 0 represents a position on the scale, not 0 in the fact of nothing. Can you guys think of something that we use in normal life? When you say 0, it doesn't mean like absolute 0 to nothing. It just means that it's a space. I'm thinking like something that starts with temp and ends with temperature. So temperature, that's right. So if you have 0 temperature outside, does it mean that there's no temperature whatsoever? No, it's still a temperature. So 0 just represents a position on a scale. As opposed to a GPA of 0.00, that means you're in trouble. Okay. Okay, guys, all there? Sorry, lots of writing, but we've got to do it. The other one, right? Just like the categorical data or qualitative data, branches into 2 pieces. Number data branches into 2 pieces, and here's the difference. Interval level means that there's intervals between, but 0 doesn't mean anything. So this is called ratio. Ratio means there's gaps in between, but also the 0 actually makes sense.
What does the 0 represent again?
This one for the ratio,
No,
0
for
actually.
the other one, just, I missed that last.
Oh, yeah, sure, go ahead. Go for it. No problem. Interval level means 0 still represents something on the scale. It doesn't represent nothing. Okay, we good?
Yeah, I'm sorry about
Yeah, no problem. Ratio. Ratio means it's dealing with numbers. But the 0 actually implies an inherent 0. So 0 actually means nothing, none. Thank you. Ratios can be formed. In fact, this one is even more impressive because 1 and 2 is twice as bigger than 1. And 10 is twice as bigger than 2. Or sorry, 10 is 5 times bigger than 2. The ratio between the intervals. That's what that last piece there. So the data set can be expressed as a multiple of another. So GPA, since you guys are familiar with that, GPA of 0, 0, 0, it actually means something. It means that you failed all the classes, which hopefully is not could happen to you. If you have a GPA of 2.00 and another person has a GPA of 4.00, right? That means they are double your GPA. So there's a ratio. Okay. Lots of writing? Hands tired yet or no? No? Good. I try to highlight the least amount of things possible. And we got a jam still. Okay. If after class, if you didn't get a slide that you really want to get a slide, tell me, I'll go back to the slide. I just want to make sure that we cover this the ground. But I want to stop on this slide just for you guys to get all the info here. So similar to interval level, yes, it deals with numbers. The 0 entry is an inherent 0. the ratio of two data sets can be formed. So 1 plus 3 is actually 4. And one data set can be expressed as multiples of another. So 4 is twice as bigger than 2, or is 4 times bigger than 1. Capacity of trucks, U-Haul. So 1,200 square feet and versus 600 square feet. 1,200 square feet is double the 600 square feet. Okay, let's jam. Okay, we can start picking on people. Two data sets are shown. Which data consists of data at interval level and which of it is a ratio level? Dun, 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 dun. Don't tell me if I'm picking on you too much, and I can stop too. I think we're back to Elizabeth. Back to you. The first one, Major League, the New York Yankees World Series victories in years. Go. And it's all about the zero, right? The way that you can kind of think about it, if you have negative numbers, if it means something, or if there's something below zero that can still be counted, automatically it's a interval, right? But if 0 is the last thing on the list, you can't go lower than 0, that means it's a ratio. So, go, Elizabeth. I'll give you an clue. It starts with I. Yes, interval, that's right. Because if let's say the New York Yankees were alive and playing in the year 0, but they also play in the year BC 12. Yeah, right? Also, does the number 1923, is it double of the next year, right? Or is it, if I added 1923 and 1927, will I get something that's useful information? That's no, you wouldn't, right? So kind of think about this here. If I add numbers together, is it useful information? Can I go below 0? And if you can't do any one of those things, it's interval. On the other side, Jacqueline, back to you. Ratio. So this guy, or interval, big quantitative data. This is ratio. So this is the home run totals, right? If American League home run total was 0, there's nothing below 0, right? And 100 or 200 home runs is double 100 home runs, right? There's a ratio difference there. And 100 home runs plus another 100 home runs will give you 200 home runs. So in math, most of the time we deal with the ratio level. That's kind of new. Okay, boom, boom, boom. This one is inside your book. I'm not sure if it's useful or not. Determine, but here's all the data. So this is nominal, ordinal, interval, ratio, right? First category, can you put all the data in categories? Yes, right? Categories, anything. Nominal data, you can't put it in order, right? Because it's just nominal is just category, right? There's no numbers ratio. Subtract data values if you want. You can't do it with ordinal because they're just a listing of something. And if you want to multiply between the two, you can't have it. Okay. This is also inside the textbook here, but we already covered all that. There's just examples. The nominal level is types of shows on the network. That's nominal data. Ordinal data is the listing of shows or the best shows on Netflix. Interval, the 0 does not make sense. Temperature is the best example. And ratio, any numbers that you can add together. Okay, guys, is that good there for all the different data sets we use? Categories and numbers. And each one is breaking up in this field. Torture was one last one here for the torture. This one's probably going to be the most complicated one for today. It's the question is, how do we collect the data? Now we have definitions of stats, 1.1, the types of data, 1.2. Now the question is, how in the world do we collect this? A whole bunch of different things we do. Some is good. This is where sometimes things falter. Just like that CDC example, right? We got all the data, there's the data that's missing. How did the collection data happen? Are we getting all the useful information? Is there error that could occur? All the good stuff here. Again. Designing a statistical study, don't need to write these down. We'll do enough of this for a long time. So here it is. What we do, Kyle does things in the district office. He identifies which of the variables of interest. Is it DSPS students from 2019? Is it all male students at West Coast College? What's the population? What are we trying to get to? And then we develop a plan to get that data. We look it up. We'll have a sample maybe to the classroom. Somehow you're just trying to get to the collection of data. Could be a sample, could be population. We collect the data. We use descriptive statistics to figure out the data, and then we make interpretations for the data. Okay, how we good? How do we collect data? First things first, is we can just do a study. And one way to do it is just an observational study. And this one is probably a little better than just a survey. This one is means you're observing something. You're observing something that happens. So you're observing a number of times the blue jay lands on its nest in the morning, a number of times it lands in the evening. Is there a difference? Is there a difference? Not a food at all. You tracking the number of minutes you spend on statistics per day. That's observation. You're observing something that's happening already. All right, let's jam. And this one here, the amount of people doing, yeah, there it is. How much you're working, how much kids in childcare, how much socializing time, how long is the bus ride home, all of this stuff. And then we get to the fun part here. Now we're setting up an experiment. So treatment is applied to part. So whenever you set up an experiment, you got to have two pieces to it. So let's go with one piece here. So you got to apply treatment to a certain part of the population called the treatment group. I should have highlighted this right here. Maybe up to that comma. And let's go there. So treatment is applied to a part of the population called the treatment group. Another part as a control group, which means no treatment is applied. So both groups are actually called experimental units because they're experimenting on both. And then sometimes the control group, they're given a fake thing. So that fake thing that they're given is called a placebo. Lots of stuff right now. So for that. All right, guys, I will tell you this real quick. Once you get your book, or if you can actually reserve the book from the library, but it is so important, especially in college, for you guys to somehow read ahead. Just read ahead. Just please thumb through the pages before you get to class. The reason is because we learn, and when you learn something, we learn something in 3 different stages. One stage is just for you to be familiar with something. So it's like the vocabulary, like, what is this going to be about, right? That's one stage. Second stage is this what we're doing in class. It's the kind of like the nitty gritty stuff, right? It's like writing down definitions or calculating something. In stage 3 is you reflect upon it and you put it into long-term memory. So what happens is if you did not read ahead and you come to class and you have no clue what the lecture is going to be about, you're trying to do 1 and 2 at the same time. But that does not work so well. So if you can, before Thursday's class, go to the library. I think there's 3 different copies of this text. Just reserve the text. It's like 2 hours, right? Just reserve it, sit down in the library for 20 minutes and just thumb through chapter 2. Okay, this is what chapter 2 is about. It's about how we display data. We're going to put in the graphs, we're going to put in this, we're going to put that. And here's how we measure data. Okay, everybody get that copy stuff now?
Whoa.
Okay, no problem. It's interesting too. I counted the number of days we're going to be here, right? And there's 27 days. We're going to see each other 27 times. And you take away 4 exams, so that's going to be 23 times we're actually going to lecture, right? 23 times we're going to sit doing this. In high school, we had 180 days of school, right? High school? I know, yeah. Exactly. So get this, 24 here and 180 in high school. So is that about like 6 times as much, is that right? So each time we come to class here, we're doing 6 days worth of high school. So that's crazy. We're doing a week's worth of high school.
In class is 2 hours.
Yeah, sure. But even in high school is what, 6 hours a day-ish, right? So that, then we're even compacting it, right? So that's pretty crazy. Actually, no, in high school, let's see, it's 2 hour period, about right?
Hour.
Yeah, so figure we'll do half a week's worth, I guess. Still quite a bit of information cramming in. Right, Tristan, talk to me. Are we good to go?
Yes, sir, we're good to go.
All right, so let's go with it here. So talk to me. Determine if it's an observational study or a setup experiment. Jose. No, you're drinking. It's okay.
Sorry.
Andreas. Andrea, what do you say? It's okay if you're wrong, because that's what we're here, right? You just blurt out whatever you think comes to mind first, and then we'll get to that in just a bit. But real quick here, class, seriously, this is not about you getting it right or wrong or whatever. We're just learning, okay? We're just enjoying the learning process here. So whenever you hear something about like placebo, or one group got one thing, but another group did not get another thing, right? Whenever you sort of see that, there's a difference between 2 groups. It is going to be an experiment right away. Okay? Observation would be you record the number of hours you spent doing homework. That's an observation. In this case, determine whether the observation. Yours? Answer is experiment. Awesome. Another way I can help you, I can say it starts with E. That's good too. All right. Next on the list, Kimberly. Go.
Observation study.
Observational study, that's it, yeah. Called them up, said, hey, how are you doing? Rate your current economic condition, whether the economy is good or bad. Gallup poll, that's cool. There it is. Okay. Another way you kind of do it is observation, you're just observing. Experiment is you're influencing things, right? You're giving drugs to one and you're not giving drugs to the other, right? Okay, so Jan, keep on going. Next one is simulation. All right, the big one, there's others underneath it, but this is the one I want you guys to write down. Simulation is a mathematical or a physical model. A model that produces the same conditions. The one major reason why people don't believe in climate change is because, well, they do or don't, but what happened was when they did this, they actually ran a simulation. So a lot of the coalition was not an observational study. A lot of stuff that came out was a simulation. They plugged it in the computer and said, oh, if this is the case, this is going to happen 20 years from now. And it was like, you can't do that because you don't know all the variables. You can't reproduce every single condition. And so a lot of people say it's inclusive. Sometimes they say yes, I'm saying no. So how about that? Scientists. Okay, there's other stuff here. I don't want you to write it down. But yeah, sometimes it's impractical or even dangerous to recreate a real life process. The reason why we use it sometimes saves money, as opposed to going and observing something. Sometimes you can't even do it. Sometimes you can't observe the sun for 2,500 years. Okay, Jan, let's go. And finally, the nice little survey.
Write down the part of the investigation.
No, I think we kind of know what a survey is. That's fine. Yeah. And surveys are carried out by people by asking them questions. I guess that's maybe the only thing there. Okay, out of these 4 things that we just studied, then dive into experiments. Experiment is something we set up. So let's take a look at that. Observation, experiment, simulation, and survey. There's your 4 different options. Let's jump into number 2, experimentation. How do you set up this experiment? How do you set it up so that it's well made? And so it gives the result that you want. That's Jan. So experimental design. How do you design experiment? All right. So what we need, 3 elements, and they got to be good, and this is where things are criticized, if they are criticized. So like the control group, that was not a good control group, or you didn't control it well enough. I think the studies that say, oh, if you have cholesterol, you'll die early, right? High cholesterol, you'll die early. And what they do is they track people, they track their cholesterol levels for, let's say, 20 years. And after 20 years, they see how many people died, as opposed to the average person. And so, yeah, the people that have high cholesterol, they died earlier. Now, the only question is, was it the cholesterol that was the problem? Is it their lifestyle? Did they actually drink too much soda during the process? Cholesterol had nothing to do with it, right? So that little piece there, control or sometimes part to it. Randomization, how did you pick the people that are in there? Was it random? Was it really random, or did you have some? And then can you replicate it? Okay, one little problem, like is something called confounding variables. Experimental design. So the cholesterol example is a good one, right? Was it the cholesterol that killed them? Was it their stress, which is not even actually thinking about the cholesterol? what's contributing to cholesterol in the first place. So you have a confounding of variables issue here. Or what's causing cholesterol? Another study is what's causing the cholesterol to go down, right? You have people that are eating a certain way. You got two different groups, or maybe even more. You know, but what happens if they're eating something that's not in their diet? Right? Control what's in that. And are they being honest with what they do? That's the other problem. Sorry, guys, lots of writing. Next one, that's one problem. Our problem is not finding the variables here. Then we have this one here, which, sorry guys, should have been like this here. This should have been highlighted right here. Trying to get my highlighter. Here's my highlighter. That should have been highlighted. And there's something called the placebo effect. Boom. So you don't know what is affecting what. That's the confounding variable problem. The second one is people that take a placebo, they get better, or they could have the same exact effect as the experimental group. So the guy that was taking anti-cholesterol medication, and he lowered his cholesterol as well. Because he thought just, and again, it's just by taking the pill itself, because his mind sort of got tricked. He's like, hey, my cholesterol is going to go down because of this pill. And whether he subconsciously changed his diet, or whether he subconsciously started eating something else, so he got the same effect on the placebo. Okay, champion. So not what we do best. So control this here. We have something called blinding out. So they used to, in the old days, when they used to do these experiments, they said, oh, you're getting the drug, right? You're getting the drug. And so after the placebo effects start happening, this is people working on statistics, right? Like, man, look at this, these people are getting. So now what they do is when you're given a drug or injection, they say, you don't know whether you got it or not. Right? They tell them this could be, or this could be a placebo. You don't know. So they're not telling them that you're getting the real thing. And so again, that at least sort of like does not trick the brain into thinking, oh, I got it. Okay. This one should have been also highlighted. And the double blind study is this right here. The double blind means the people that are looking at the numbers don't know whether you got it or not. So a quick study maybe like this would be trying to test whether hyperactivity is caused by sugar. This was a study a while back. So kids were given, like if there's like 30 or 40 kids, they were given, some were given sugar, some of them were given something that tastes like sugar, but it wasn't sugar. And so then they were able to go to a playground. Then you had the teachers or whatever, or the experimental people, they did not know which kids got the sugar, which didn't, but they were made to observe which kids were more active and which ones were less active on the grid. And so there it is. So the people that are recording the experiment don't even know who got it. And that usually for studies, that's the highest level. Like, wow, you don't know who got it, and the people observing don't know who got it. So there should be some kind of effect there. Lots of stuff to write down. We're still jamming. Okay, can I go on?
Oh, one second.
Sure, no problem. Sorry, I go back. Okay, first. All right, that's dealing with the control aspect. How do you control the experiment? How do you best control it?
Pretty good, boss.
Cool. Next, let's move on to randomization. How do we randomize how we pick the groups? So now we're talking about people or things. How do we pick it in such a way that it's really, really random? And we have trouble with this. And so, again, a study can be criticized was, well, did you pick a random sample? Was it really randomized or not? So part of it is we just randomize things. So somehow, if we're looking at doing a study, an experiment, we randomly pick West Hills College students for a study. How do you pick them? You pick them off the statistics class. But hold on, if you pick them off the stats class, how about people that can't even do stats? Would that give you a different effect on the study, right? Or you can say they're looking at study habits. Look at study habits of people, right? You can't do the stats class because you guys are cool. You guys do study. And then the other class, they don't study, right? So then like, well, you're not going to get a good range. So how do we do this? We do a completely randomized design. So Kyle, good guy at the district office, what he does is he gets a generator, a random number generator out. And he goes, click, I need 20 students, randomly selected, click. And so random number generator are one way to do that. Another one is this right here. So you got to solve a little problem. What happens if the random number generator still picks all the kids in the statistics class? Is that a bad thing? Maybe. But is the data going to be skewed for number of hours studied? Because you guys are in a transfer level math class, right? You guys hopefully learn how to study well. So we have something called randomized block design. So not only are we going to pick just random students at West Hills College, we're going to pick a random student from the Math 6, just the Math 25 class. Then we're going to pick a random student from the algebra classes. And then we're going to pick some random students from the pre-algebra classes. Oh, good. So that, and then we're going to see the study habits of West Hills College. Does that give us a better indicator now? Okay, let's talk about this little bottom one before we do the next one. So how do we divide people? That's algebra, pre-algebra, that's a good way to divide. This is a good example. Tell me if you guys are good. Sorry, go back there. See people still writing out. So cool. So randomization, if you would randomly pick it. Let's see. Jay, the person that does the cafeteria at Whitfield College, right? Every single year, they do. He does a survey of how the food is the food good, is the food bad, is there good choices? So what he does is I think he just naturally selects every third person that walks through the door. Right? That's a randomization process, right? Then you move on to the next one. How can you completely randomize the design, right? So then you're thinking about, okay, do I include, when people walk through the door, maybe every third person, but then also maybe every female and every male, right? And maybe people that live on the dorms, also people that don't live on the dorm, right? Now you're talking about randomly selecting. So now, there it is. There's the randomly walk. You look at something like a weight loss program. Okay? So the weight loss program, you know what, I can't just randomly pick people. I probably should pick them according to age. So maybe there's gonna be something there, right, according to age. And then you figure control group and then the treatment. Okay, one more, this time. Something called the matched pair design. So this is more of matching people that are very similar in traits. So not only by age, but maybe the same body type. So you have people in the 40 to 49 age category, you have 100 of them, but then you're also going to make sure that, okay, these people have this certain body type, these people have another. I'm going to give these people, or randomize those people with certain. But this is really, it's called match pair. So you have one person. Okay, good, almost there. We have 10 more minutes to go, so I'm going to see how far we get here. We might not get to sample. Okay, another thing, experimental design also super duper important is just the sample size. Always. Question really comes up is there enough sample size? I was in a district meeting a year ago. And statistics, usually, we talk about at least 30 people just to sort of have a sense of something. But remember our little 839 people to look at all the US employees? I don't think 839 people is good, right? To judge based upon the US, all employees in the US, right? So this sample size is like not enough people there. All right, and one more thing to think about is this whole concept, can this be repeated? Can I replicate this design? Experiment. Large group, another large group, totally different subjects, will this be? Let's go. Tell me you're done. Tell me if you're not done. Okay, no problem. How I'm gonna skip the example. Let's go to sampling technique and then we can be done there. Cool. So I'm gonna skip the examples, just so we can get done. Let's go to sampling. How do we sample stuff? Different samples. How do I get the data set? I set up the experiment. I randomized it. We're gonna just kind of go real quick here, just the pieces here, just so you guys can see here. Okay, census. What is a census? Census means you're getting the entire population numbers. Every 10 years, the US does it. If you are just trying to get a certain amount, then you have yourself a sampling is a part of a population, not getting everyone. And usually you can't get all of it, right? Especially here, sometimes. So the question is, how do you sample? And we're gonna go just real quick with this. Then we have time. And this whole concept is you want to randomize it. Somehow you want this to be a random sample. How do you do that? How do we make sure it's random sample? Oh, and I should put this here. Because we're doing sampling, we're not testing everybody. Even the best methods we use is still going to have some kind of error inside it. At least some kind of error. The question is, how do you mitigate those errors, or can you only infer so much of the whole population? Good to go. I got 6 things for you here. So first things first is there's kind of 2 ways to think about statistics. First of all, it's just a random sample, so every single person in the population can get it. And then whenever we say simple random sample, then we're talking about sample size. Right? So we're going to pick 6 people out of this. That's when numbers can be embedded have at least a good sample size there. So title, district office. You look at study habits. And he's going to pick from the whole entire population. He's going to pick a group of 50 students. And they will get tracked to see how much homework they do early. And we can generate them. If he does it, district office, he pulls all your student ID numbers right into a computer system. And the computer system randomly pulls it. And we have 4 minutes left here, so I'm going to do this here. I'm going to just go get you guys the definitions for each one. So we're going to go here, we're going to skip the example problems for now. This is just random sample by student ID numbers. Then we've got all the different ways we do it. And each one of them has its pluses and minuses. We're almost done, guys. I got 1, 2, 3, 4 things to write down. Okay, in order to have randomness as much as possible, what we sometimes do is we sometimes divide things into groups. So J at the cafeteria, you'll go with dorm students and non-dorm students. You're gonna pick one person from there. That's called stratified sample. And the groups have to be kind of small. So you are dividing into groups, and then you're selecting members from a group. That's stratified sample. Just so you know, you have at least a good amount. When they ever do poll data, right, they should divide it into Republicans, Democrats, Independents, and they should randomly select those people. Right? Okay, Jan, next is cluster sampling. Here it is. You're going to divide the people into groups like you did last time, except instead of taking members from each group, what you do is you're just going to focus on one group. This is usually done when you're looking at, it's hard to get to people. So you figure that people that live in West Ridge County, all of them are taking the same. And then you go to just those blocks over there, just the neighborhoods right there. And you're going to sample those people. Assuming that zone 2, zip codes 2, 3, and 4, they're probably going to give you the same amount of numbers. Two more guys, we're done. And 2 minutes to go. Lots of writing, so understand. Thursday won't be as much writing. Promise. Okay, 2 more. Here is this cluster. So there's one called systematic sampling. To the starting value, and then it's a certain amount of members here. So this happens in our teacher meetings. Seriously, we sit up in the group, and the person says, "Okay, I'm going to count you guys off. There's 1, 2, 3, 4. All the 1s go here. All the 2s go here. All the 3s go here. All the 4s go there." There it is, systematic sampling. Every certain person. Oh, that's right, Jay. The cafeteria, right? Every third person that enters the door gets a survey. That's what this is. And the last one, not the best one to use, but it sure works still. Boom. Last one. Just get whoever you can get. So let's see. Oh yeah, this one is usually what customer satisfaction surveys in stores, right? When you come out of the store, like, tell me if this was great or not great or something like that. People that had an experience, they're not going to put anything down, right? People that have awesome experience, they'll put it down, and people that have a negative experience, will put it down. Usually it's towards the negative. Or let's see, our president in the past, she used to also send a survey in the year, and to everybody, and about 8% of the people actually voted. So either you were like really cool or like this sucks, right? Guys, thank you so much. I know there's a lot of writing. Come to me if you want to talk to me about something here. Or adding. Otherwise, I'll see you guys on Thursday with your core packet. Get outside, take off your mask, breathe fresh air.
Oh, now the other things that I get to.
Oh, you want to go on
Yeah.
It's gonna go on the same list.
Let me say, let me just.
Instructions on set. He just got right.